Hey everyone, this is a video to help you with the part of the project where we're going to be solving using the quadratic function. So in your project, you're going to be solving this quadratic right here with the leading coefficient of 8. And you're going to be solving it in the way that Tahini describes here. She says, I like to treat it like a quadratic function, but I use the quadratic formula to find the solutions. So your job in this slide is to solve this quadratic here using the quadratic formula. So to help you, I will be solving one similar. Let me find it first, though. So here's a very similar quadratic equation to you, and she says we're going to treat it like a quadratic function. So first thing I'm going to do is move this 2 to the other side so that it's written in standard form. So that would, positive 2, moving it over would become a negative 2. Now it's set to 0. And I am going to be solving or thinking about this as a function. So that means that I'm really going to be thinking about it in terms of having inputs, which are x, we see here, but also I need an output, and I'll think of it as y. You could have also called it f of x or h of x, g of x, whatever you want to name this. So to solve using the quadratic formula, I hope you have the quadratic formula written down somewhere. But we are solving for x, so it starts with x equals negative b plus or minus the square root of b squared minus 4 times a times c. All of that is under the square root, so I like to kind of put a notch there to remind myself, like, hey, all of that is under there. And then it's all over 2 times a. So quadratic formula has a, b's, and c's all over in it, so I need to identify my a, b's, and c's here. So written in standard form, where I have x squared, x term constant, your a is always going to be that first leading coefficient. The b value is going to be the coefficient with your x, in this case it's a positive 3, and then your c value is just a normal constant, because it doesn't have a variable, so it doesn't vary, it's constant. So now I have identified my a, b's, and c's, so now I can just plug this in. So it starts out with a negative of b. So I have a negative of b, which is a 3. So it looks like it's a negative 3, but it's a negative of my b value of 3, plus or minus the square root of b squared minus 4 times a times c, and again, all over under the square root, all over 2 times a, which would be 2. Okay, and then now I'm just going to be following order of operations, or PEMDAS, to be able to simplify this. So looking here, I need to take care of my exponent first. So now I have 9 minus 4 times 2 times this negative 2, all over 2 times 2. Okay, and then now I'm going to perform multiplication. So here I have a negative 4 times 2, but then times another negative 2. So this would have been a negative 8 times another negative 2, would be a positive 16, all over 4. Okay, and then 9 plus 16 is 25, all over 4. Hey, that was kind of nice, because I know what the square root of 25 is. It's 5. So I'm going to simplify that. 5 over 4. Okay, this is where I'm needing to split apart the plus and the minus. So think about that quadratic formula. We have the negative b plus and minus. So we need to represent both of those options. So this is where I like to split it apart. I have a negative 3 plus 5 that is being divided by 4. And I have this negative 3 minus 5 that is being divided by 4. So now if I simplify this, negative 3 plus 5 would get me a 2 that's being divided by 4. So final answer is a fraction. Fractions are all right. Negative 3 minus 5 would get me a negative 8. Divide that by 4. Negative 8 divided by 4 is a negative 2. So there are my two solutions. Okay, don't forget to show all of those steps in your own problems and in your own writing, and please reach out to your teacher if you have any questions.